Okay, so um, now we are going to talk about two things. I'm going to talk about this device and this device, the two of them, this one and this one. So what is this? This is called an overspeed governor. The overspeed governor has got a very important role in ensuring that the lift has got high safety standards. So why is it called an overspeed governor? Every lift is designed with a particular speed. For example, if you have 3 floors, or between 3 to 5 floors, or even to 10 floors, you might choose to use 1 meter per second. If you are using 1 meter per second, the software on the drive is rated for 1 meter per second. Now, the software will check whether the lift is moving at 1 meter per second based on 2 factors. One is we have what we call the speed encoder. The speed encoder is installed at the back or at the front of the motor. It is checking the revolution. It is checking the revolution of the speed of the lift. And there it is. There between the two fans, you have got a speed encoder. It is a tackle. Yes, that is a tackle. So as soon as the drive commands the lift to run, that movement is measured and the reference value is stored on the drive. So the drive knows that the lift is moving at that designed rate of revolutions. Now, where the safety comes in is that the lifts are designed with high safety standards. One of the major safety standard is the overspeed governor. When the overspeed governor is constructed, it is constructed with curves. So whenever it is moving on a curved end. And that curved revolutionary end can trigger the actuator here, which is a mechanical actuator. It is powered, it has got a voltage here. So this overspeed governor cannot move beyond the design. For example, this one is designed for, you can see here, the speed is 1.6 meters per second. So whenever the overspeed governor is moving, if it moves beyond 1.6 meters per second, the vibration is going to trigger the electromagnetic switch. There are 2 switches. There is this one, and then there's one which is at the end here. I'll come and have a look. There's one which is at the end here. There is this one here. This is the one that normally is triggered to electrically disconnect power, which is that one, this one. So this micro switch is connected directly on the safety circuit. It is directly connected on the safety circuit. So once the magnet micro switch is activated, due to the high vibration, because if you increase the speed here, you're going to have more wobbling, and because you have a high wobbling, the switch is designed with an actuator here that should the vibration increase, it triggers that switch. So once that mechanical switch is triggered, the voltage on the safety circuit is disconnected. That's the first safety. So first it disconnects the safety circuit power supply. That's the first safety. Then the second safety is because now the high revolution, it is forced to activate the brakes. On every lift, we have what we call brakes. The brakes are installed at the bottom of the lift, and they move with the lift. Now, they can only be triggered by the overspeed governor. As you can see, the overspeed governor here is connected to an actuator here. Are you seeing? This is the actuator for the overspeed governor. So this actuator will pull this, and when it pulls this, then the brakes are going to be activated. These brakes are mechanically activated to hook on the guides. It actually hooks onto the guides. So once it's activated, it hooks on the guides, and once it's hooked on the guides, then you have, the car doesn't move. It will only move for 1 meter. That is by design. It will slide for only 1 meter, but it will be tight onto the guide, very tight. So that's what will stop the lift if it is moving beyond the rated speed of 1.6 meters per second for this particular lift, because the speeds, as I said, are designed initially before the lift is supplied, and the determination is the height of the building. Is what determines the higher you go, the more speed you need. So okay, the lowest we can say is 1 meter, then 1.6 meters, then you have 1.75 meters, then you have 2.5 meters, then you can go on up to 10 meters per second. There are lifts now which are designed for 10 meters per second, and those are for high-rise buildings that are moving maybe 50, 60, 100 floors. They're designed for 10 meters per second. So but those ones are not using, they are not using this method for checking the speed. They're using infrareds. But now this one particularly, that's how it is designed to operate. So once the actuation has taken place and the lift has stopped, it won't move again until it is mechanically disengaged. So there are 2 rods at the bottom here. Those 2 rods are hooking on the brake pad, just the way, for example, this one is. So once this one is pulled upwards, it is engaged. So for it to go down, you have to hit the top of the rod. Then it lowers the what? It lowers down the brake pads. And then once the brake pads are away from the guides, once they create, they are normally moving between 0.8 and maybe about 3 millimeters. So if you look at it, the brake pad is moving so close to the guide, that it's about between 0.8 and about 3 millimeters. So once it's activated, it hooks straight onto the guide, and for you to lower it, you have to knock it downwards and to disengage, because it is designed in a rectangular way. The design is it has a rectangular end. So the hooking end, once you lower the hooking end, it detaches from the guides. So basically that is the first line of safety on the lift, and the most important safety on every lift is to ensure that you can manage the speed of the lift. It should not move beyond its design speed. That is involuntary movement. So the software, as I told you, is checking it from the tachometer, which is the speed reference value it gets from the encoder. It is also, the software also is able to recognize that the lift is moving involuntarily, and because it's moving, it goes into software error. So it creates an error which can stop the lift. But the real safety is on the overspeed governor, because he has got 2 principles. One, One is the mechanical brakes, which are on the guides, which hook on the guides. The second is the micro switch, which is connected on the safety socket. The safety socket line is checking all the safeties on the lift. So this is one of the safeties on the lift. And also on the brakes, these brakes on the guides, they are also being checked by a micro switch. See, there is a micro switch here. Are you seeing this micro switch? This one. This micro switch here is, once the movement is done, it will activate the switch here. Are you seeing? So this plunger here will activate the switch. So as much as the top one has activated, this one was also activated. So this is also a safety socket micro switch. There are two of them, one on this side, one on the other side. So these are all on the safety socket. So those are acknowledgements, are in the electrical acknowledgements, are a set of this. We call them KF switches. The KF switches are two connected to the brake. So once the brake is activated, it triggers off that safety line, which is on the safety socket. So this micro switch, that one and the other one are all on the safety socket, and they are being checked by the control processor. So the control processor is permanently checking the safety socket. Is it closed? If it is open, it won't allow the lift to move. So it must be closed, and closed in the proper way. If you create a loop, it will sense that there is some loop. It will not exactly. It may work, but it is extremely dangerous to think of creating a loop unless you are a highly professional engineer working on it. Usually, it is done during commissioning. Once the commissioning is done, all the systems are put to their factory requirements. So the safety circuit line is not looped. It is connected to the micro switches. If the micro switches, they are all connected. There's no loop, there's no wire. If it is the second safety is on these doors. These doors have got they have got these contactors. These contactors are door interlocking contactors, and they are also connected on the safety line, safety circuit. So you have so many switches connected on the safety circuit. If you open this one like that, the lift won't move because it is noticing that there is an open circuit here. This circuit is open and they are all in series. So this is another safety on the lift as a series circuit. So that is just among them. Then in the pit you have buffers. Those buffers, if they are hydraulic, then they have got switches. If they are not hydraulic, they don't have switches. If they are mechanical, they are just mechanical. If they are hydraulic, they have switches. So you have those switches also on the buffers connected directly on the safety line. So all these are on the safety line. So you have buffer switches, 1, 2. Then you have got stop switches in the pit. All those are safety line connections. The other safety on this one, also we have what we call a trap door. Because this is its design is a Eurolift. Now it is called machine roomless. It was first produced in Europe. So you have this trap door. It's also a switch, and this switch is also connected on the safety line, together with the overspeed governor and the door and the pit switches. Then all that is also on the safety line. Then you have a stop switch here. A stop switch is also on the safety line, so that is another safety on the lift. Then you have got another stop switch on the drive, on the door drive. On the door drive there is a stop switch which is also connected on the safety line. So basically I've summarized the safety circuit on this particular brand of lift. As I said, the safety circuits are in series and every circuit has got a monitoring circuit. So we have LEDs there on the control processor, on the interface processor, which is checking the circuits individually. If you activate it, you are able to identify the circuit that it is the door drive or the stop switch or the overspeed governor, because every circuit is individually checked by the control processor. So that sums up this one.